Geotrig, day 4. We're going to continue with lesson 1. We're talking about area and perimeters of triangles, so we're still talking about those triangles. Now we have to start talking about the other ends. We talked about angles, and we talked about the types of triangles. Now we're going to talk about how do you find area, how do you find perimeter, all of those things. How do we calculate the area of a triangle? I think we all should know this. 1/2 base times height. Good. 1/2 base times height. Sometimes people like to do base times height and divide by 2. That's fine. And what does the area tell us? What is area?
How much is on the inside?
What's that?
How much is on the inside?
How much is on the inside? How much space does it take up? Two-dimensional space, right? How many square units that it has? You guys can kind of fill in what you would like to put on that one. How much space is in it, right? How much is in it? Perimeter is the what of the shape? Outside. How about this? Make it a little bit more exact for any object instead of just the outside. Because if I have a triangle, there's a lot of outside stuff. If you think about it. Like, here's a triangle. This is inside, right? Except for that last part. So this is all outside. Is that included in the perimeter? No. So be careful, I guess, when we using definitions and things, that we're a little bit exact, but yet we still can be a little loose with the terminology so that more people can get access to it. But I would say the perimeter is the distance around. How about that? Distance around the shape. And I'm going to massacre that word. Cinnamon roll. What's another word? Another word. Okay, we're gonna fix this. Whoops, that should be one word. Another word for height is? No, it's not cinnamon. So we could say the height of a triangle, a height of a rectangle, things like that. Usually when we talk about triangles, it's actually called the altitude. Actually, if you think about, if you're in an airplane, you're flying in the sky, and the pilot will come on and our altitude today is 5,275 feet. Or something like that, right? And our cruising speed is 1 knot. That would not be good. I don't think you're flying at 1 knot. But have you guys ever heard that word before?
Yes.
Okay. So altitude is another way of saying the height. Now, there's something important that you have to realize about a height. When I draw certain triangles, like this one, we can definitely see that that's not an equilateral triangle, right? A couple sides are longer than the other side. We would assume that the base of this triangle is right here. If that's the case, then the altitude is from the highest point straight down. There. And an altitude forms what kind of angle with the ground? Something straight up and down, it forms what kind of angles with the ground? Right angles. So an altitude, when you're told that something has an altitude of 5 meters, you know that when it's on the ground, it's going to meet the ground at a right angle. Okay? Now, here's the thing. This is all relative. If I make this the base, like if I was to actually rotate this triangle, then the altitude would probably be more over here, right? Do you kind of see that? So it's kind of relative of what we're calling the base. Whatever the base is, an altitude would be straight down perpendicular forms right angles. Very important. It's nice to know, because as we do more problems, they start to use words like that, and you have to make the assumptions or know that's what they mean. It helps us give us more context clues to finish the problem. Like in number 4 there. It's telling you that an equilateral triangle, that means it gives us a particular shape and size, or shape, sorry, has a perimeter of 24 meters and an area of 16 square root of 3 meters squared. Find the altitude, aka height of the triangle. Notice that it's just a bunch of words. It's a word problem. Get used to it. But what does it not have with this problem? What's that?
Like the shape.
The shape, the drawing. So what should you possibly make? Make a drawing. So, it has to be an equilateral triangle, so that's pretty easy, I think. Doesn't have to be perfect, it's just a representation, yeah? Okay. What other clues do we have about this special equilateral triangle?
Perimeter.
It's got a perimeter, which means the distance around it is 24. But we know something about equilateral triangles, that all of the sides are the same. So therefore, if there are 3 sides and they add up to 24, each side is 8. Okay, so I think everybody would have been able to do that. But then it says that we have an area of 16 square root of 3. What is the altitude? So in this case, I drew my triangle kind of in a nice way, right? Flat bottom going to a peak. If I had to make an altitude here, naturally I would start at the top and go to the bottom. So let's draw an altitude. So there's your altitude. We know it forms a right angle. And since I don't know the altitude, aka height, I'm going to call it h. Would that be acceptable? H for height? And what's the last piece of information they gave us? I underlined it. Okay. Or so the piece of information they gave us that help us put all of this together is 16 square root of 3. But that is the area. So maybe what I need to do is go up here and say, hey, there's a formula for area. And that formula is A equals 1/2 base times height. The question is, there are 3 different variables in that equation. A, B, and H. You need to know 2 of those to solve for the last one. Do we know A? Yes. A is the area. What is A? 16 square root of 3. 1/2, we know 1/2. 1/2 is 1/2. What about B?
8.
It's 8 because it's the base of my triangle. It's right there. And do we know H?
No.
So we're going to leave it as H. And now, can you solve for H? Can you simplify the right-hand side? 1/2 of 8?
4.
So it's 4H. 16 square root of 3. Divide both sides by? Divide by 4. Now, some people might get confused about this part right here. 16 square root of 3 divided by 4. Square root of 3 is an irrational number. It's inside a radical square root. But 16 is multiplied to it on the outside. We're dividing by 4. I can simplify the fraction 16 divided by 4. And 16 divided by 4 is?
4.
And square root of 3 goes along for the ride. So 4 square root of 3 is the height. You will notice this book will use square roots, pi, 3.14, la-di-da-di-da, and e, 2.718, la-di-da-di-da, a lot. But they're not going to use 3.14. They will use pi. They will leave answers in square roots of 3, square roots of 5, square roots of 7s. You guys should have last year, potentially I think it was from last year, how to simplify a square root. That's one of those things we will do a little bit later on. But it's always a good habit to know how to do that. And if it's in 5 pi plus 3 pi, so if you happen to have an answer that said 5 pi plus 3 pi, it ends up being 8 pi. And that's your answer. Unless it says 1 or 2 or 3 decimals. Then you use your calculator button, work it out. So now we're going to talk about parallel lines being cut by a transversal. Actually, I just kind of gave away some of our parts here. A blank line is a line that cuts or intersects one or more of the same in the same plane. So when 2 or more lines on a board here are cut by this thing, this line, it's called something. I said it earlier, it's actually the first word on the board there. Transversal. A transversal is a line that cuts. It's lagging big time on the screen for you guys. A transversal is something that cuts lines that are in the same plane. We generally cut through parallel lines. So if the blank cuts through parallel lines, again, transversal. If the transversal cuts through parallel lines, blank and blank angles are formed. Ooh. Wait a minute. What kind of angles are formed when I have something like this happening? These are parallel lines. Line 1, line 2 are parallel, cut by its transversal, we'll call T. What kind of angles are you seeing? Complementary, supplementary angles. I could see supplementary angles.
Yes.
Going to complementary, I'm not sure if I see that one, because these are a lot of straight lines, which are 180. So therefore, I like the supplementary part. But I'm thinking like 1 and 3, 2 and 4. What are those called?
Straight.
No. Starts with a V. Vertical. They are vertical angles, so we have some vertical angles. They're vertical angles. So, we are going to backtrack on that vertical stuff. I'm going to take that out. And we're going to put in there, wow, that was bad, acute and obtuse angles. First, there are vertical angles that are formed. That's going to be towards the bottom here, as I messed up my own outline here. When the transversal cuts through parallel lines, there are acute and obtuse angles that are formed. What I want to look at 3 there, though, is that what do you think about 1 and 3, 5 and 7, 2 and 4, 6 and 8? They look to be the same. What about 4 and 8? 4 and 8. They look to be the same. 3, 7, 2 and 6, 1 and 5. They look to be the same because they are the same. There's names for all of these. So, 3 and 6. 3 and 6, though, oops, here. 3 and 6 are not the same. Those have a name. And these are called consecutive. Consecutive angles. Consecutive angles add up to 180. Okay? Put that consecutive angles, 3 and 6. 3 and 6 add up to 180. They're consecutive angles. Whereas 3 and 5, 3 and 5, one on each side. Does anybody remember what those are called? It's 2 words. Alternate. Are these inside or outside? They're alternate interior angles. So what if I called those alternate interior angles? What do you think 2 and 8 are? 2 and 8, alternate exterior. Here's the thing. Alternate interior angles, alternate exterior angles are the same. But consecutive angles like 3 and 6, 4 and 5, they'll add up to 180. So maybe put add. Sorry. That's a bad add. But add to 180. You guys hopefully have seen some of those before. If not, that's why we're doing this. So alternate exterior, alternate interior add up are the same. Consecutive angles add up to 180. Next. Actually, I'm going to go back. We also have our vertical angles, right? Vertical angles. Vertical angles. So look at this. So it's kind of hard to see that now. 2 is equal to 4. Right? So 2 is equal to 4. 6 is equal to 8. Would you guys agree with that?
Yeah.
Those are vertical angles. But 4 and 6 are also equal, aren't they? Because of alternate interior. If I change colors here, 1 and 3 are the same. 5 and 7 are the same because they are vertical angles. And 3 and 5 are the same because they are alternate interior angles. Do you guys notice that it forms a zigzag pattern? All the purple or odd numbers are the same, and all of the even are the same, or red. That's something we got to think about. It's very helpful if you can just kind of zigzag your way through some parallel lines. So, if you knew that, and I told you angle 6 in this diagram is 55 degrees, the two lines are parallel, can you tell me all of the other angles?
Yes.
I would hope you should be able to say yes. Even if you've never seen these before, just getting the notes from today. Where's angle 6? Angle 6 is here, and that is what? 55? So what other angles are 55?
3, 2.
3. Why is 3 55?
Alternate interior.
Alternate interior. Okay, what else?
2.
Why?
I forgot.
You got a couple options for this one.
Um,
If you knew 3 was 55, 2 is 55 because they are?
alternate.
No.
Vertical.
Yes. They are vertical angles.
Oh, yeah.
If I only knew angle 6, I know angle 2 is 55. Actually, we talked about it, not recorded. Didn't put it on our notes. But 2 and 6 are what we call corresponding angles. Corresponding angles are the angles that if I cut out angle 2, I could pick it up and I could drop it onto 6 right here, and it would be the exact same angle. So 2 and 6, 1 and 5, 3 and 7, 4 and 8 are all what we would call corresponding angles. We should have put that on the last slide. And what other one is 55? 7. Again, because we can claim vertical angles or corresponding angles, or one more. If you knew 2 is 55, 7 has to be 55 because of alternate exterior. Now you need to know what 1, 4, 5, and 8 are, and they happen to all be the same. How do we know that one? 180 minus 55. There's 180 minus 55 because they all form straight lines or straight angles with a 55. So, what is 180 minus 55? 125. 125. 125 and 125. Notice zig, zag, pattern. Now, this is something like you would definitely see in our homework. Given that lines L and M are parallel, N is the transversal, find all angle measures. As you guys are writing that down, is the problem asking you to solve for x? No. It's asking you to find all of the angle measures. Are you going to have to find x in that process? Yes. X is not the answer though. This is a multi-step problem. Look where 4x plus 10 and 8x minus 25 are. What's so cool about those two positions? What's so cool about this position and that position? What can we say about those two angles? They are the same. And if these things are the same, can't I set them what can I do with these two things? They represent the same angle. That means they're the same value. So can't I set them equal to each other? Isn't 4x plus 10 equal 8x minus 25? Yeah. And then I solve it. That's fairly simple to do. But you had to realize that these are corresponding angles. And corresponding angles are the same. Moving 4x or 8x? Move the 4x. Subtract 4x. 10 equals 4x minus 25. Then I will add 25. 4x equals 35. Oh, that's it. Why are they so mean? Divide by 4. So guess what your answer is? 35 over 4. Are we done? We solved for x. We're done. I need to find the angles, guys. So, you guys have to be 100% okay with answers, though, of 35 over 4. This is not Algebra 1. This is not Algebra 2. We don't always come up with nice numbers like 5. We now come up with numbers that are fractions. We come up with answers that have square roots. Okay? It's okay. But it might shake out better because you have to put that answer into the equations. Now, these are both the same thing, aren't they? They're going to give me the same answer. So wouldn't it make sense to put it in the smaller one? Okay. 4 times 35 over 4 plus 10? What happens to the 4's? That's the beautiful thing about it. What happens to the 4's? Cancel. 35 plus 10 equals 45. So we know 2 of our angles so far. 45, 45. Wait a minute. If we know 2 of them, we actually know how many more? We know all of them actually because of the zigzag pattern, don't we?
Yeah.
So that means I should be able to say, hey, that's 45. And that's 45. Yes. So what's the other angle? 180. That's a bad 8. That is a bad 8. 180 minus 45, which equals 135. 135. 135. 135. 135. And you just did the problem. Day 4's homework, page 12, 8, 21, 22, 24, and 25. Have a great day.